I'm not making a static mixer. There, I said it. I think it's more complex as far as the actual machining of that. All those little baffles and stuff. What a mess, right? Imagine something getting stuck in there too. You can't take it apart to clean it. Plus, with a static mixer, you pretty much get what you get. And you're stuck with it. With a moving mixture, I could experiment with different temperatures, different mixing speeds, that type of thing to change my results. With this, it's like it's just going to mix how it wants. So I think it's better to have actually a moving mixture like my original patent that I chose. So basically, what I'm saying is this. We're thinking of going with this patent from our original video from 1961. This mixer right here. Except, so here's the motor, here's the shaft, here's the mixing paddles. They mix around inside this cylinder, and out pops the foam here. Now, we were going to mix chemical 1 and chemical 2, which when combined form gases in here, according to this machine. But, a lot of these patents we've been reading say, and this is where the molten foam comes in, through an extruder. A lot of these patents are saying that you should just send the molten foam through an extruder, through a feed hopper. So put the pellets in the hopper, have them go through a screw extruder, through this pipe, down into the top of this chamber. Also put in your stabilizers and, what's that name? Nucleating agents. Okay, so you mix all that in at the start with the actual pellets of foam, and all those are coming through, getting mixed up real good in the extruder, and then they'll get mixed up finally here. And instead of 2 reactants to form the gas, we'll just pump in actual gas. So this top one, so we're actually getting rid of 19. We're getting rid of this. We're just going to pump in CO2 right here. And now the CO2 gets mixed up through here, and then it comes out well mixed. And we can control the flow rate and the pressures and everything based on how hard we're pushing in the CO2, how hard we're pushing in, the speed at which we're pushing in the foam, the size of the exit tube, the speed of these paddles will need to correspond with the speed we're passing fluid through the mixer. And then it'll come out and be perfect. And we can control everything. It's a physical foam making when you just pump in CO2 air. It's called a chemical foam mixing if you pump in 2 reactants which form bubbles when mixed in this mixer. I'm telling you, I'm finding a consensus. All of the patents for polyethylene foam making that are modern say to pump in CO2, not reactant. So, yeah, I'm thinking of going with this. Now, modern day foam machines don't use a mixer because it's cheaper than having to turn this powerful motor which just stirs this highly viscous fluid, and that takes up a lot of energy. It's cheaper for mass production to use a static mixer, which, well, that was in the last video we just showed. Right here. This is a static mixer. Okay, the red fluid enters and the tan fluid enters, and they go through a series of baffles which confuses the fluids, and they're being pushed in by pressure, and as their pressure is being relieved as it comes out the low pressure side, they're being pushed through, and they're weaving amongst each other and getting chaotic, and that causes them to mix. My gripe with this is I think it'd be hard to know like how thorough it's gonna mix and stuff like that, and I just have to like buy a bunch of them and see what length I need and all this stuff, and a lot of experimentation, and possibly more expensive. Whereas if I make my own mixer like in this patent, it's literally just a motor, which I already have, and a piece of metal I already have, and then the shell of this is just going to be an empty can, and I have that can actually right here. Here's the shell. It's just garbage, a can. And I mean, how much simpler can that be then? And I can make it myself, and it's all free. And I'm not worried about the little electric that turns this motor. I'm not going to be like running a foam factory 24/7. No, I don't think you'd ever have to clean it, and here's why. This will all be full of molten plastic, but you would have this chamber. The whole mixer needs to be heated to the melting point of the plastic foam that you want to use. So when you turn it off, you shut off the valve at the bottom, which is right here, and you shut off the intakes, you shut off all the intakes, and now it's just going to be hardened. With trapped air inside this, it's going to stop turning. It's just going to be a hard, thick thing, and it's going to get cool, and it's just going to be hard foam with compressed air packed tightly in it that wasn't able to expand. So it's just going to be like rock hard with a lot of pressure in it, of trapped gases under pressure. And that's it. When you want to use it the next time, you simply raise the heat of the whole mixer, which can be done with resistance wire, nichrome wire wrapped around the mixture. The mixture's temperature can be raised up to the melting point of the plastic, and then once it's at that melting point for some time, the entire solid piece of plastic would fully harden, fully liquefy, and then you can turn back on the mixture and begin the process and start producing foam again. I don't think you would ever have a time where you would need to clean it. I feel like if I ever did want to just empty it fully and inspect it and do maintenance work or whatever, instead of feeding in foam, at some point I would feed through maybe paint thinner or water, and at high temperatures have that push out whatever plastic's in here and just force it all out. And I feel like it would still be stuck. What would I use? Oil or something? Something that would loosen it, and it's still under high heat. So yeah, it wouldn't be stuck because it's still high heat. So everything's molten still. Remember, it's all liquid. So yeah, I think you could use any liquid, and in that high heat, it would just push its way through and clear out all the stuff, and then just drain it out. The water would just drain out then when you cool it, and then you'd just be left with a clean machine. In theory, I think. So I don't think it'd be hard to clean. I think you just push water through it at high temperatures, and all the liquid plastic would just fall out. But in theory, I would want to think that it would be years you would never clean it. Why would you ever clean it? Because even the act of liquid plastic passing through, wouldn't that push out any impurities and just be a natural cleaning process as a highly viscous liquid plastic under heat is forced through? I feel like any rust, any impurities, anything would just be naturally washed away and shoved out and turn into part of the foam that's exiting. I feel like you wouldn't ever have to take this thing apart to clean it, in my opinion. But obviously that's all speculation. I don't know for sure. So yeah, I'm going to go with this design. I really like it, and I still think it's compatible, and you don't need a fancy static mixer like this. It's cool to watch this animation. It's very cool. I love the technology. I get it, how that saves energy. I mean, you're taking out a lot of energy that you would have had to turn this big honking motor to mix up the foam. I get it, but I bet you need a lot more pressure on the intakes to make something like this work. Something that viscous would have to be pushed under tremendous pressure to shove this thick fluid through all these little tiny openings. It would want to get stuck. You'd have to have tremendous force. Whereas with this, I feel like you can just kind of push in the plastic and push in the air kind of more chill, and it will get stirred up in a much larger open area by a high-speed spinning paddle blades. And so you're kind of using a lot of energy to create that amount of pressure anyways over here, and you're just trading using energy over here that's movement energy. I guess the big gripe people would have is if you're dealing with movement, you got to replace the motor once in a while. I mean, I don't get it, because you're going to deal with movement anyways with your pumps that's pumping whatever it is in. Your extruder that feeds in the molten plastics dealing with motors too. So I don't know. I don't see. Maybe I'm missing something, but it doesn't seem like it's that big of a deal to have to use something like this. And like I said, I think that a stainless steel, lots of little parts like this thing, is more likely to clog, and you'd have to just throw it away if it clogged. There's no taking it apart. It's too complex to even get in there. It's like if it clogs, you're done, I guess. But I don't know for sure. Plus, if I bought something like this, I would need to be careful in how I heat it, I guess. Maybe it'd be the same though, just wrap nichrome wire around it. So I guess I take that back. That wouldn't be too much of an issue. Would it be easy to pump CO2 into the high temperature pressurized chamber? Yeah, I would just use hydraulic pumps. No, they're called gear pumps. Gear displacement pumps. Gear displacement pump. So this is how that looks. It could even be just a 3-geared lobe pump, as you can see right here. Basically, these just turn, and everywhere you see an arrow is where the fluids get shoved through, and you can actually just, depending on the speed with which you turn the gear, that directly correlates with the speed with which the fluid passes through, and the pressure would correlate with how fast you're letting it out. So if these pumps can just keep pumping no matter what, the pressure will build and build and build until you start letting some out. Then the pressure starts to lower, just like on a airbrush thing or an air compressor. So this is the same principle. Depending on how much volume I let out of the mixer, these will need to be pumping a lot harder if I let the volume out quicker. But if I let it chill in the mixer for a long time, then these don't have to work as hard in order to provide the pressure we want of CO2. Sure. I still got to read all this stuff, but I feel like we're just kind of now making sure I don't miss anything, and also gaining consensus. The more patents I read, the more I can see what's the accepted state of the art and where I can diverge from that, so that when I go to price buying materials and stuff, I can see like, well, I did see examples of patents where that material's used and it's cheaper, so I'm going to go with that. Or I shouldn't buy this material because all the patents said you should go with this other material. So there's no getting around doing a lot of research, in my opinion, to make sure that you're being thorough enough. So that's a lot of reading. This is the part that would bore you guys, but this is the part that will guarantee my success by really having a sound grasp and a lot of knowledge and great notes. So basically, the original patent from the 1960s said to use 2 agents, mix it into the molten foam, and it will work. But it never mentioned polyethylene. So I did a bunch of research into 10 different polyethylene specific patents and came to the final conclusion that that 1960s patent actually does apply to polyethylene, and that's probably my best bet, is to mix 2 things. It could be baking soda and white vinegar. It could be baking soda and citric acid. It can be baking soda and sulfuric acid. It can be yeast and hydrogen peroxide as my 2 components that will mix up in my mixing chamber with the molten foam and produce carbon dioxide as an after effect. Now, big industry just gets free carbon dioxide because they get 1 million pounds of it. They produce it themselves because it's in the air, and they prefer to do that rather than buying a bunch of baking soda and hydrogen peroxide, which would be more expensive, or buying baking soda and vinegar or whatever. It's actually cheaper for them just to buy huge semi-truck sized tanks of CO2. That's why they pump CO2 directly. But for a small scale operator like me, I don't want to have to buy a CO2 tank. For me to buy an actual big tank, a 200-pound tank, that's like $1,000 to buy the tank, and then I got to drive that on the roof of my wife's car to a welding supply place and ask them for refills of CO2, and they'll probably charge me $100 to fill it and give it back to me 3 days later, and I got to go pick it up or something. That's ridiculous. Like, for a small scale operation, it's so much cheaper and more practical just to buy a little box of baking soda and buy a little bottle of white vinegar for like $5, and that will last you for like hundreds of pounds of foam making. So it's just that's the discrepancy there, but it's going to work just fine. And whatever water is in that vinegar or whatever, because it's mostly water, I believe actually will dissolve or evaporate and make its way out of the foam over time. It'll take maybe months, but it will actually dry out eventually. Because why do I say that? Because it's closed cell foam. You'd think, oh, it's airtight. How would the air get out? It somehow does by some magic, because some companies actually use flammable gases to create their pores for their foam, and they then wait for some months for that all to evaporate out of the foam, and then it gets replaced by ambient air from the room that it's stored in, and so it's no longer flammable and a hazard. So somehow, no matter what you use, air gets in there, and whatever gas you use gets out. And so I guess it's not truly closed cell foam, even though it's said to be. It's not like literally. It's still quote-unquote waterproof, but I guess it's not like truly airproof over a long period of time. And in fact, if you put it underwater for a really long period of time, it'd probably start to soak in the water as well. It'd probably start to saturate with water. And I've seen that with polyethylene foam, that if it's underwater for a real long time throughout the day, it starts to get a little heavier because it takes on some water. Yeah, it's not truly airtight. It's got very slow leak. Okay, so that completes all of my research, and I'm now so much more knowledgeable and confident going forward. I had all these questions, and I wasn't sure, and the patent was from 1960, and they weren't really specific, and it had no mention of polyethylene, and so they were mentioning some weird chemicals that aren't really available nowadays, and it just seemed like kind of sketchy. But after seeing all the modern patents about polyethylene foam making, and cross-referencing all of them and reading a book about it and learning a ton more, I found out that pretty much that old patent fully applies unchanged, except the modern materials, like I said, are probably going to be baking soda and white vinegar, just like my electrolysis setup is. No, my electrolysis is white vinegar and Epsom salt, not baking soda. Baking soda and white vinegar could not be used for electrolysis because it bubbles violently, giving off CO2 gas when you mix them together. And that's actually exactly what we want in our foam in our molten liquid foam mixture, we want that violent production of CO2, because that CO2 is going to pressurize inside the chamber as it tries to escape, and we're going to mix it into the mixture and form all of these little pockets of tiny CO2 bubbles that are pressurized, and when it comes out of the mixing chamber, it will be able to expand, and that will form the big air pockets that makes the foam grow. So we're all good. Everything, all my fears and stuff are now assuaged, and that was pretty much my goal today, is to fill in my knowledge gaps and grow my confidence, because this is a big, expensive project as far as like time commitment and fabrication, and how embarrassing and frustrating would it be if I just completely failed and lacked the knowledge to know what to do and had to redesign the machine or start over after months of, you guys know how long it takes me to build something like complex like Atom. It's a big thing when I have to do something like that. Even though this machine's way simpler than Atom, it's still going to be a lot of work, and the last thing I need is to work my butt off and then get discouraged at the end. But that for sure will not happen now, because I know everything involved. I know exactly why the machine is the way it is. I know the difference between modern machines and this, which is mainly that modern machines took away the motor with the mixer, and instead they just put it through what's called a static mixer, which has got like a bunch of baffles that when you force fluids through it, they mix each other just by going through all these little curved baffles. And that's about it. That's the only difference. But I don't mind going old school and just using a motor that actually turns the mixing paddle. It's just a little less energy efficient. That's the only reason why a big industry doesn't use it, because they run this stuff 24/7. So if they can save $1 a day on electric costs, they do it. So that's the only reason for the difference. Console, it's not at all a waste. I had to verify exactly what materials I'm going to need, exactly the method that I have chosen, that the machine that I'm building from the 60s will actually work today with modern technology, that there's no issues with it, that actually does work with polyethylene. I had to verify all my plans and fill in all my knowledge gaps and take thorough notes so that I can go forward in utter confidence, 100% certain that I will succeed with this. And building a polyethylene foam machine has been a dream of mine for quite a while, because it can save me $70 a month in foam costs, and that's just with my company here. My company is going to be here someday, in theory, if it continues to grow or I put money into advertising, and that savings will go a lot higher, maybe $400, $500, $600 a month in just pure savings. And money saved is money earned, so my company will be a lot more profitable. Even just $70 a month now, how would you like to get $73 a month? Like, that's huge. That's awesome. I definitely want it. And it makes me no longer dependent on the fickle foam suppliers who can raise their price at any moment. I don't want to be dependent on them. So, yes, I stand by it. You guys always complain if I don't make progress on my big projects. Well, this was huge progress on a big project of mine. Not every project is pure taking action. R&D is a very important part of doing projects. You can't just blindly try to build something not knowing what the hell you're doing, because then you're going to fail. And that failure won't be a bad form of failure, but it will be a waste of time, because if you would have learned everything you needed to know, you could have avoided a lot of the trial and error that would come with doing something the wrong way first and having to learn the hard way. I would rather know exactly what I'm doing before I start. That's why even before doing a car repair video, I'll watch like 5 videos on YouTube covering that same topic, so that I know exactly what I'm doing, and I've learned from several different people all the tips and tricks, and then I can just nail it the first time. So that's very important. Something so complicated as building a machine and all the chemicals involved and all the options involved, there are many ways to do it. And to understand all of that and weigh out the options and come up with the most cost-effective and appropriate option for my application was a big task, and I completed that. Not everything's going to be physical. Just to have all these plans, to say, I'm going to build a foam machine, Daddy, oh, like a little baby. He's like, sure, Tommy. That means nothing. to have a step-by-step to-do list for exactly how you're going to do it, and start buying the materials and sourcing everything, and to know exactly how it's going to work, and all the options for what materials you could use and which ones are the most cost effective, and have everything planned out and be able to start actually shopping. That's tremendous progress. So getting all the research out of the way puts me that much closer to the physical part, and also the actual buying of everything. Yeah, I'm going to eventually build a plastic shredder which will shred down water bottles, which can produce polyester fabric. After I shred it down and then put it through a string making machine, and then put it through a loom to weave it into fabric, I'll end up with polyester fabric, and I can use that polyester fabric to produce inventions that I have that require polyester fabric cloth or another comparable tough fabric cloth. And that will save me money on buying cloth. And as I continue to scale my businesses, the more ways that I'm able to use recycling and produce my own raw materials, or not raw materials, produce my own, I mean, they're kind of like raw materials. Buying cloth for a clothes maker, that's like a raw material for a clothes maker, for example. So to be able to produce my own raw materials from recycled materials is really cool. To bring the cost to the absolute, like, unbelievable lows that are absolutely incredible. Like, if you can use all recycled materials that are free, you can literally make products for free, minus whatever labor you put in. But if you have robots do it, I mean, you literally have zero cost at all. At all. And those robots can be powered with free electric from my dad. But even with that, I have plans to install a solar system for our house so that it won't even cost my dad money, and I'll be saving him money on electric. So I got it all figured out, boys. You might as well not dive into one, because what if the machine that I was building doesn't even apply to polyethylene? How stupid would that look if I build a machine from the 1960s that won't work for polyethylene, and it allows me to make the wrong kind of foam? And that's what I was very much in risk of doing before knowing if this machine would even be viable. So you're saying just dive in and start building a machine that I don't even know if it even relates to the type of foam I'm making. And it never even says it can make polyethylene foam. How stupid would I be to then build that machine and take months doing it if I don't even know if it works for polyethylene? And if it didn't work for polyethylene, you guys would be the first ones to call me an idiot for not doing a little more research and making sure it's the right type of machine. I would look like a fool, and you guys would be right in calling me a fool, because I would have wasted my time due to impatience to get to the action steps, because I was unwilling to do the research. So you should always do your due diligence before jumping in and wasting a lot of time. What part was complicated? Yeah, there's UV stabilizing additives for foam. See, as the maker of the foam, you don't need to know anything about that. You just buy the additives from the chemists who made those additives. You don't have to know how it works chemically. I'm not getting involved in the chemistry. I have to understand the basics, but I don't have to design chemicals or anything. No, it wasn't. That wasn't hard at all. It said it in the patents. It said, cell stabilizers. It would say, like, it's useful to further reduce the density of the foams produced and results in thickness increase. A cell stabilizer agent from another patent said is recommended to be added, which is said to prevent the foam from collapsing while it cools due to loss of blowing agent to the atmosphere. So when you read what a cell stabilizer does in multiple patents in different ways of explaining it, then you get a better understanding, because each patent might explain it in different words or describe a different benefit. Nucleating agents are said to help to increase cell density, which will also make the cell structure more regular and give the final form softer surface. From another patent, it said it forms a crystalline structure, which is what forms the polyethylene bubbles. So that's the nucleating agent additive. And other patents even said how much percentage by weight to add of nucleating agents and cell stabilizer. So we know what it does, we know what percentage of it to add in, and we know the name of it, so we can actually go out and buy it. And it has different options. You can either use sodium bicarbonate, or talcum, or talc, or zinc oxide, or silica. So you have some options. You can buy the one that's cheapest or most available to you. And the blowing agents, they talk all about what the agents do and the different options and different cost comparisons, and you can pick the one that works best for your machine and your setup. It's like so simple. The hard part was being able to sit through and wade through so much information that was not useful, like mathematical calculations of the tear ratio of the molten liquids or the shearing of it and all this. Like, ugh, like I don't need to know those formulas and stuff. That's ridiculous. Yeah, some people said that the air in the air we breathe in and out, whatever, has too much oxygen content, which degrades the foam. I actually read that in the book, that oxygen degrades the plastic. But I would argue that that's pretty much BS, honestly, because it also said that when they use flammable gases to blow up the foam, they have to let the foam sit and rest, they call it, allowing the flammable gases to escape from the foam slowly and get replaced by the surrounding air from the room, which tells me that the foam is not actually airproof anyways, and little by little air replaces whatever gas you use. So even if you did use CO2, that CO2 is going to slowly leak out into the atmosphere, and just the room's natural air is going to flow in, which has oxygen anyway. So that's actually BS. You can just use normal air. But it's actually better, in my opinion, just to use baking soda and vinegar to produce CO2, because that will produce it with a lot of violence and create a lot of pressure for me. And that's also how the machine, there's only one foam making machine that I was able to find where it had pictures of the machine and a description of how to make this machine. And that is what I'm going to go off of. It was from 1960. And that machine used two chemicals that produce CO2. So, when mixed together. So that is the route I'm going to go, rather than trying to pump air into it, because that would be a whole different machine design with different considerations. I want to go with something that's proven and that was used in industry at one time, and that I have detailed description of how to build it. The foam forms its cells just by shoving air into melted plastic and then mixing that air up, just like shaking up a can of pop or beer or something. If you took maple syrup and you put your straw in the bottom, you started blowing in it violently, it would bubble up, and then you could shake it or stir it up, and then it'd be lots of little bubbles in it. And if you put a lot of little bubbles in it under a lot of pressure and then opened it up, it would grow in size, because all the bubbles would be expanding in their individual little bubble pockets, and the foam, it would become foam. But because it's maple syrup, it wouldn't cool off, and the foam would just slowly just settle down and form a puddle on the ground. But if you had actual plastic that, when cooled, turns into a solid, it would be solid foam, and that's how it works. It's I think pretty intuitive, I think it's pretty simple. It's just fill it with air, stir up the air. The air expands after it exits the machine. After it exits the mixer. We won't even call it a machine. It's just a mixer. Everyone knows what a mixer is. It's just a cup with a spoon stirring. Basically, that's all a mixture is. A mixer is just a stirrer. It's going to be closed cell, yeah. Open cell foam, I learned so much that I can answer even the difference between open cell and closed cell manufacturing. Open cell foam would be a foam whose walls are so thin and the pressure is so high that the gases erupt, busting through the cells as it cools. And the cell walls aren't thick enough to actually contain the gases, so it all rips free, creating lots of imperfections in the cells, and it becomes open cell, and so it can actually absorb water like a sponge. And that's how they make car seats and mattress foam and sponges and everything like that. You would just use like a mixture of molten plastics that will be really soft and weak, and don't add any cell stabilizers, and make sure the gas pressure is really, really high, and the gas will just rip it apart as it cools, causing it to be open cell. The cells aren't closed, they got ripped open by the gas. So that's actually simple. My same machine that I'm building could make open cell foam too if I just change the formulations of what I'm putting in it. And I can even control the size of the cells based upon the amount of pressure of gas and the stirring speed. And I can control the strength of the cells and the thickness of the cell walls based on the amount of stabilizer I add. And I can control the toughness of the foam by adding in more polystyrene to my polyethylene to make it more fluffy. Guys, when I read that, I was learning a lot. I wasn't just looking at it with an empty brain. I'm not an idiot. You guys all think I'm dumb, but I'm not. I actually understood most of what I was reading. And I have high retention rate. I learned a lot, but I only wrote notes on stuff that I felt was relevant to what I'm trying to do. You do think I'm an idiot. Everyone does. Even my own family. People think I didn't even graduate from school because I flunked out. But I told you guys I had the top GPA in my university and nobody believes me. But I can prove it. I have the plaque. I was valedictorian at the university level.